Hi, good afternoon to all. This is Srikanth Reddy, P. Lecturer in Electronics and Communication Engineering Department, working at Government Polytechnic, Jogpet. Today we discuss the subject microwave communication and television. Subject code EC405. In this chapter, today we discuss four topics. First one, define primary and secondary constants of a transmission line. Second, define group and phase velocities in transmission lines. Third, define reflection coefficient and SWR, standing wave ratio. And fourth, list two types of distortions in transmission lines. First topic, define primary and secondary constants of a transmission line. Transmission line means to transfer the energy or signal from one place to another place. Here, this transmission line contains two major parameters. The parameters of transmission line divided into two types: primary constants and secondary constants. Primary constants are resistance R, inductance L, capacitance C, conductance G. Secondary constants: characteristics impedance Z0, propagation constant P, attenuation and phase constant, and wavelength. Primary constants: resistance, inductance, capacitance and conductance are called the primary constants of transmission line, which are defined as a resistance. It is defined as the loop resistance for unit length of line. It is the sum of the resistance of both wires for unit line length. That means, in a equivalent diagram of transmission line, loop resistance or for unit length of line is called resistance. Its units is ohms per kilometer. Second one, inductance. It is defined as loop inductance for unit length of line. It is the sum of inductance of both wires for unit line length. That means in a equivalent transmission line diagram, the loop inductance or series inductance for unit length of line is called inductance. Its units is henries per kilometer. C. Capacitance. It is defined as shunt capacitance between the two wires for unit line length. That means in equivalent circuit diagram of a transmission line, capacitance is shunt connection or parallel connection. So it is the shunt capacitance for unit line of length between the two wires. Here capacitance and conductance are in parallel, so we take it as two wires between them. So its units are farad per kilometer. D. Conductance. It indicated by G. It is defined as shunt conductance between the two wires for unit line length. That means in a transmission line equivalent circuit diagram, conductance is shunt or parallel connection. So shunt conductance between two wires for unit line length is called conductance. Its units is mho per kilometer. These four are the primary constants. The primary constants are derived directly from the transmission line. Second one, secondary constants. The secondary constants are derived from the primary constants from transmission line equivalent circuit diagram. These primary constants are R, L, C and G. Use these four primary constants, we derived the secondary constants, characteristics impedance and propagation constant. First, characteristics impedance. It is defined as the ratio of voltage to the current at the input of infinity line. That means it is the impedance. Impedance means it is the ratio of voltage to the current for the transmission line input of infinity line. So Z0 equal V by I, voltage by current, is called characteristics impedance. The characteristics impedance of a transmission line Z0 is defined as the impedance measured at the input terminals of the line when the line is infinity line. That means we taken the transmission lines for some meters to so many kilometers. So we taken as infinity line length as example. In this line, the impedance measured at the input terminal of the line when the line is infinite is called characteristics impedance Z0. Next, propagation constant P. The propagation constant at a uniform transmission line for unit length is defined as the natural logarithm of the ratio of steady state voltages or currents entering and leaving the structure. That means in a transmission line we taken as input for the starting point, output for leaving for the entering end of the line. In that line in the transmission line, the natural logarithm of ratio of steady state voltage to current or steady state voltages or currents for entering to the leaving currents, entering to the leaving currents or entering voltage to leaving voltages. That's called propagation constant. That means P equal to log E I1 by I2 or log E V1 by V2, where I1 is the entering current, I2 is the leaving current, V1 is entering voltage, V2 is leaving voltage. That means P equal log E I1 by I2 or log E V1 by V2. Or propagation constant is equal to the square root of the product of series impedance and shunt admittance. That means P equal to square root of Z into Y, where Z is series impedance and Y is shunt admittance. The square root product of series impedance and shunt admittance is called as propagation constant. Next, attenuation constants and phase constants. Here the propagation constant P is given by P equal to alpha plus j beta. It is a complex number. So here alpha is called as real part, beta is called as imaginary part. Here alpha is taken as attenuation constants, beta is taken as phase constant. So attenuation constant alpha, the real part alpha is called attenuation constant. It determines the attenuation or reduction in voltages and currents along the line. That means in a transmission line, any reduction of voltages or currents in a transmission line is called as attenuation constant. Its units are Nepper per kilometer. Phase constant. The imaginary part of the propagation constant beta is called as phase constant. It determines the phase variation of a voltage and current along the line. That means in a transmission line, any variations of the voltage and current with respect to phase variation. That means phase variations in a voltage or current in a transmission line is called phase constant. Its units are radians per kilometer. So attenuation constant and phase constants are alpha and beta. These two are summation by propagation constant P equal to alpha plus j beta. And next one, fourth, wavelength. It is defined as the distance that the wave travel along the line for one cycle. That means any wave travels a distance along the line for one cycle or 2π radians. That means the wave travel a distance from 2π radians or one cycle is called as wavelength. Wavelength is denoted by lambda. Units are meters. Lambda equal to c by f, velocity of wave. C is f is frequency in hertz. Next, define group and phase velocities in transmission line. Group velocity. Group of different frequencies travel with different velocities through a transmission medium is called as group velocity. Group of different frequencies travel with different velocities through a transmission medium is called group velocity. That means more number of waves are traveled in different velocities through a transmission medium is called group velocity. That means group of waves traveled in a transmission line. It is denoted by Vg. Vg equal dw by d beta. Group velocity is less than the phase velocity. That is called Vg less than Vp always. Group velocity always less than the phase velocity. Phase velocity. It is defined as the velocity with a single of signal frequency propagates along the line at a particular frequency. That means a single signal frequency propagates along the transmission line. That wave's velocity is called as phase velocity. Or it is the velocity of propagation along the line based on the observation of phase change along the line. Any phase change in a transmission line, or if the wave changes its phase when it travels in a transmission line, is called as phase velocity. It is denoted by Vp. Its units are kilometer per second. Vp equal W by beta. Next topic is define reflection coefficient and standing wave ratio SWR. Reflection coefficient. It is defined as the ratio of reflected wave voltage to the incident wave voltage. That means it is the ratio of reflected voltage to incident voltage. Reflected coefficient can indicated by K equal to VR by VI. Reflection voltage VR, instant wave voltage VI. The ratio of reflection wave voltage to incident wave voltage is called reflection coefficient. Over R, it is also defined as the ratio of reflected wave current to instant wave current. That means K equal to reflected wave current to instant wave current. That means K equal to IR by II, where IR is the reflected wave current, II is the reflected wave instant wave current. Next topic, standing wave ratio. The ratio of maximum to minimum amplitude of a current or voltage along a transmission line is called standing wave ratio. That means it is the ratio of maximum to minimum voltages or currents in a transmission line is called standing wave ratio. Is again divided into voltage standing wave ratio VSWR, current standing wave ratio CSWR. Voltage standing wave ratio. It is the ratio of maximum voltage to minimum voltage along a transmission line is called voltage standing wave ratio. That means maximum voltage to minimum voltage of the ratio. The ratio of maximum voltage to minimum voltage is called voltage standing wave ratio. VSWR equal Vmax by Vmin. Vmax is the maximum voltage, Vmin is the minimum voltage. Current standing wave ratio ISWR. It is the ratio of maximum current to minimum current along a transmission line called current standing wave ratio. That means it is the ratio of maximum current to minimum current in a transmission line. ISWR equal to Imax by Imin. ISWR is current standing wave ratio, Imax maximum current, Imin minimum current. These are the 4 definitions: standing wave ratio, voltage standing wave ratio, current standing wave ratio, ISWR, VSWR. Next topic, list 2 types of distortions in transmission line. What is mean by distortion? When the received signal is not exact replica of transmitted signal, then the signal is said to be distortion or distort. That means if any signal is given to the circuit or the electronic device, the output is not same as the input. The output is not same as the input, then the signal is called distortion or distorted signal. That means the received signal is not exact same replica of or not exact replica or same as transmitted signal is called distortion. There are two types of distortions present in the transmitter wave along the transmission line. Distortion are basically given two types. They are frequency distortion and phase distortion. Frequency distortion. The output signal frequency is not same as the input signal frequency is called frequency distortion. That means in any circuit, the output value, the output frequency is not same as the input frequency. The output signal frequency is not same as the input signal frequency. Then the signal is called as frequency distortion signal. Phase distortion. The phase of the output signal is not same as the phase of the input signal is called phase distortion. That means the output of the signal changes its phase. It is not same as the input signal phase. The output signal phase variation to the input signal phase signal is called phase distortion. Otherwise, any distortion, any change in the output phase of the signal compared to the input signal is called phase distortion. The phase of the output signal is not same as the phase of the input signal is called phase distortion. Briefly discuss about above topics. Today we discuss four topics: define primary and secondary constants of a transmission line, define group and phase velocities in transmission line, define reflection coefficient and standing wave ratio SWR, list two types of distortions in transmission line. First one, primary and secondary constants of a transmission line. In a transmission line, we taken as the resistance, inductance and capacitance and conductance are the primary constants. That is, in a equivalent circuit diagram of a transmission line, R, L, Cg are the primary constants which are directly taken by their values by resistor, inductor and capacitance and conductance. and secondary constants means which are derived from the primary constants, that is RLCG. Primary constants: R means resistance, L means inductance, C means capacitance, G means conductance. Resistance: it is defined as the loop resistance for unit line length, unit length of line. Its units are ohms per kilometer. Inductance: it is defined as the loop inductance for unit length of line. Its units are henries per kilometer. Capacitance: it is defined as shunt capacitance between the two wires for unit line length. Its units are farad per kilometer. Conductance: it is defined as shunt conductance between the two wires for unit line length. Its units for mhos per kilometers. Here, in a transmission line, resistance and inductance are in series, that means loop and we taken as. Capacitance and conductance are in parallel, we taken as shunt. So, shunt capacitance and shunt conductance, series or loop resistance or loop inductance. So, we taken as R and L are in series, C and G are in parallel, that wise C and G called as shunt capacitance and shunt conductance. R and L is called as series resistance and series inductance or loop resistance or loop inductance. Secondary constants, which are the primary constants are used to derive the secondary constants. Secondary constants are derived from primary constants RLCG. So, in this we have two types, two characteristics impedance Z0, propagation constant P. Characteristic impedance Z0 equal, it is the ratio of voltage to the current at the input to infinite line. Z0 equal to V by I. Propagation constant, the uniform transmission line for unit length of line, it is the natural logarithm of ratio of steady state voltage to currents. Steady state voltage to natural logarithm of steady state voltage to voltages or currents entering and leaving the structure. That means in any transmission line, entering voltage to leaving voltage or entering current to leaving current, their natural logarithm is called as propagation constant. That means P equal to log E I1 by I2 or log E V1 by V2, where log E is the natural logarithm, I1 is the entering currents, I2 is the leaving current, V1 is the leaving entering voltage, V2 is the leaving voltage. The another formula, another definition for propagation constant is, it is the square root of the product of series impedance and shunt admittance. That means P equal to square root of Z into Y, where Z is the series impedance and Y is the shunt admittance. Attenuation and phase constants. Propagation constant is it is the complex number that is called A plus J beta. This propagation constant indicated by alpha plus J beta. The alpha is called as attenuation constant, beta is called as phase constant. Alpha is the real part of the real part of the transmission in phase propagation constant. Beta is the imaginary part in propagation constant. Alpha means any attenuation or reduction in voltages and currents along the line, along the transmission line. That means any reduction in voltage or current in a transmission line is called as attenuation constant. Its units are Niffer per kilometer. Phase constant means is the imaginary part of propagation constant. It determines the phase variations of voltages and currents along the transmission line. In a line, any phase variation of voltage and currents is called phase constant. Its units are radians per kilometer. And next one is wavelength. It is defined as the distance that the wave travels along the line for one cycle. That means that the wave travels along the line for one cycle or 2π radians. In a 2π radians, the wave, how much distance traveled is called wavelength. It indicated by lambda, lambda equal to c by f. Lambda is wavelength in meters, c is the velocity of wave meters per second. Meter per second. F means frequency in hertz. Next, define group and phase velocities in a transmission line. Group velocity. Here, group of different frequencies travel in a different velocities through a transmission medium is called group velocity. That means the waves travels, the different waves or the group of waves traveled in transmission line with different velocities is called group velocity. That it is indicated by Vz. Vz equal dw by d beta. Always group velocity is less than the phase velocity. Phase velocity. It is defined as the velocity of the signal of a single frequency propagates along the line for particular frequency, or any phase changes along the line in a transmission line of velocity Vb. If the wave travels in the transmission line, the wave changes its phase variations is called phase velocity of single transmission line, single wave. It is indicated by Vp. Vp equal to omega by beta. Define reflection coefficient and standing wave ratio. Reflection coefficient means it is the ratio of reflected voltage to incident wave voltage or reflected current to incident current. It is denoted by K. K equal to VR by VI or IR by II. VR means reflection wave voltage, VI means incident wave voltage, or IR means reflected current, II means incident current. That means it is the ratio of reflected wave current to incident wave current. Standing wave ratio. The ratio of maximum voltage to minimum voltage or maximum voltage to minimum current, maximum voltage to minimum voltage or maximum current to minimum current is called standing wave ratio. maximum to minimum amplitudes of voltage or currents along a transmission line is called standing wave ratio. Is voltage standing wave ratio VSWR, current standing wave ratio ISWR. Voltage standing wave ratio, that means it is the ratio of maximum voltage to minimum voltage. Vmax is the maximum voltage, Vmin is the minimum voltage. The ratio of Vmax by Vminimum is called VSWR. Current standing wave ratio, it is the ratio of maximum current to minimum current along a transmission line. ISWR equal to Imax by Imin. Imax means maximum current, Imin means minimum current. Imax by Imin is called ISWR, current standing wave ratio. Last topic, list two types of distortions in transmission line. When the received signal is not same as the transmit signal, then the signal is called as distorted or distortion signal. That means any signal is given to the circuit, the output and input. The output signal is same as the not as the input signal. The output signal is not same as the input signal is called distortion or distorted signal. So this distortion is two types in transmission lines: frequency distortion and phase distortion. Frequency distortion means the output signal frequency is not same as the input signal frequency, is called frequency distortion. That means the output signal frequency is not same as the input signal frequency, and the signal is called frequency distorted signal. Phase distortion, the phase of the output signal is not same as the phase of the input signal, is called phase distortion. That means in any circuit we given the signal, the output signal phase is phase variation to the input signal phase signal, input signal phase. That means the output signal phase variation to the input signal phase is called phase distortion. That means any variation in the output phase signal to input phase signal is called phase distortion. Okay. These are the today topics. First one is primary constants and secondary constants, and second topic is first topic is primary constants and secondary constants definitions, and second topic is phase velocity and group velocity. Third, reflection coefficient and standing wave ratio. Fourth, distortion, types of distortion, many types of distortions in a transmission line. So we have frequency distortion, phase distortions. Define primary and secondary constants of a transmission line. Define group and phase velocity in a transmission line. Define reflection coefficient and standing wave ratio. list two types of distortions in a transmission line. This is the today discussed topics. Okay, thank you. Thank you to all.